in vertex form, you got a couple options. So a lot of people go in with completing a square, which is fine. My suggestion is what I would do. I would go x. All right, so we go x. X is equal to the opposite of b over 2a, right? Okay, so then I'm going to plug in the opposite b, so negative 12 over 2a, which is 8. So that gives me, that'll reduce, but those have 4 go into them, so it gives me negative 3 halves, right? Okay. So when I go through and write my f of x in vertex form, okay, that is the coordinate right now of my vertex, the x coordinate of my vertex. That makes sense? To find the y coordinate, then I take f of negative 3 halves. Okay? So I've got 4 times negative 3 halves squared plus 12 times negative 3 halves minus 8. Okay? So when I multiply these, how do I square a fraction? Yeah. Top squared, bottom squared, right? Or just rewrite it as negative 3 halves times negative 3 halves, right? Okay. So it gives me 9/4. Okay. What's the benefit of having that 4 out front? Cancel. So just going to be 9 there. Okay. Over here, the 12 and the 2 are going to cancel, right? Gives me 6. 6 times negative 3 is negative 18. So I got 9 minus 18 minus 8, right? So 9 minus 18 would be negative 9. Minus 8 more would be negative 17, right? So I've got negative 3 halves as my x value, negative 17 as my y value for my vertex. All vertex form functions are, quadratics are of this form. A, x, minus your center, okay, or sorry, not center, vertex, minus your vertex. So it's minus a negative 3 halves. So it would be plus 3 halves, right? Squared, and then plus your y coordinate of your vertex, so plus the negative 17. Now, I just got to pay attention. If I multiply that out, if I FOIL this out here, will I get 4x squared? No. So what's my a coefficient have to be? It has to be 4. Okay, so that's what we're looking for there. You could have gotten the same thing by completing a square and all that kind of stuff. But I think that's probably quicker, and it's going to involve a little bit less algebra. All right, a little bit less calculation. All right, so what's the vertex of that? Then you would have said negative 3 halves, negative 17, right? Okay. Now it's a positive 4x, so this thing's concave up, right? So this thing's got to be a minimum, right? Okay. Now it says what's the y-intercept? Well, the y-intercept is right there, isn't it? Okay, the y-intercept is x is 0, y is negative 8. Okay. How many factors does this thing have? We talked about if I have a leading degree of n, that's how many factors I have, right? So this thing's got 4 factors. How many possible turning points? Okay. It has that minus 1, so it's got 3. Okay. Now, if you kept going and said, well, all I wanted was the maximum, okay, if you would have said it could have also 1, okay, that's fine as well, okay, so 3 or 1. So that's the end behavior, okay, so this is a 4th degree polynomial, but it's concave down, right, okay, or x-axis reflect, I don't know if you would consider it concavity, but as x goes to positive infinity, y is going to go to negative infinity. And as x goes to negative infinity, y is also going to go to negative infinity. So it's a negative infinity on both rows. Possible zeros then for this one. Remember, these are your p-values, so plus or minus 1, 2, 4, and 8. Q's are plus or minus the factors of 3, 1, and 3. So our p over q's are going to be plus or minus 1, 1/3, 2 and 2/3, 4 and 4/3, and an 8 and 8/3. Yeah, those are the things I'm looking for. Now, how you wrote it as plus or minus, you wrote each one of those out, positive 1, negative 1, comma, 1/3, comma, negative 1/3, that's fine. Those are the ones I'm looking for. All right, so the last one. Now I don't have the picture, so is it? Let's see here real quick. Or something like that, right? All right, so what does this tell me? What does this thing right here, this 0 tell me? X plus 3 squared. It's the lowest degree multiplicity of 2. The reason they say it's lowest degree is so that you can differentiate whether, because a 4th degree is going to have the same behavior here, right? A 6th degree is going to have the same behavior. Now, it might be a little bit more kind of steep as we approach that intercept, okay? But that multiplicity is guaranteed to be 2 if we say lowest degree. Oh, you're fine. This one here tells me a factor of what? X minus 2, right? So I'm looking for P of X to equal X plus 3 squared times X minus 2. Okay, now that will give me that behavior, but that will not go through 0, negative 4. Okay, I need a particular coefficient to go through 0, negative 4. So what we do is we know that this A value out here, okay, is what we're looking for, and we're going to use this point 0, negative 4. Okay, so if the Y value is negative 4 and the X value is 0, come on, 0 plus 3 would be 0 minus 2. So 3 squared, right? That'd be 9 right here. This would be negative 2. So it gives me negative 18 times A, which is equal to negative 4, right? Does A become 2/9? Does that make sense, everybody? So the P of X that I'm looking for would be 2/9, X plus 3 squared, X minus 2. Now, if you FOIL that out, you can, that's fine. But that's ultimately what I'm looking for. The most points for that question, and I didn't put the point totals on here, but most of the points are going to come from you having that. Okay? If you've got that, I'm happy with that. Now we got to make that step to find that 2/9. Understanding that there's an infinite number of functions that pass through negative 3 and 2 in that manner. To find that one specific that also goes through 0, negative 4 is going to be important for us. Okay? All right, let's talk. I got